Alright, so in this problem, I have x to the power of 4 is equal to x minus 1 to the power of 4. So to solve this, I'm going to first start by subtracting x minus 1 to the power of 4 on both sides. So then these two cancel out, and now I have x to the power of 4 minus x minus 1 to the power of 4 is equal to 0. Now, x to the power of 4, that's the same thing as x squared to the power of 2. And x minus 1 to the power of 4, that's the same thing as x minus 1 squared to the power of 2. So now this is equal to 0. Now, if I have something in the form a squared minus b squared, this is equal to a plus b times a minus b. So in this case, a is x squared and b is x minus 1 squared. So now I have x squared plus x minus 1 squared times x squared minus x minus 1 squared. This is equal to 0. Now, x minus 1 squared, let's go ahead and expand that. That's going to equal x squared minus 2x plus 1. So I have x squared plus x squared minus 2x plus 1 times x squared minus x squared plus 2x minus 1. Because remember, you got to distribute the negative sign. And this is equal to 0. So now, let's go ahead and simplify this. X squared plus x squared is 2x squared. So I have 2x squared minus 2x plus 1 times x squared cancel out. So just 2x minus 1 is equal to 0. So now this gives me two equations. I have 2x minus 1 is equal to 0. And I have 2x squared minus 2x plus 1 is equal to 0. So for 2x minus 1 equals 0, x is simply equal to 1/2. That's a simple equation. And now for 2x squared minus 2x plus 1, we're going to use the quadratic formula, which is negative b. So negative of negative 2 plus or minus the square root of b squared negative 2 squared, which is 4, minus 4 times a, which is 2, times c, which is 1. And all of this over 2a, so 2 times 2, which is 4. And now this is the same thing as positive 2 plus or minus the square root of 4 minus 8 is negative 4 over 4. And as you can see, we have the square of a negative number, which we can't do. So my only solution here is x equals 1/2. So x equals 1/2 is my answer. Alright, so in this problem, I have 9 to the power of x minus 9 to the power of y is equal to 648. So for my solution, I'm going to first start by looking at x and y here. So obviously, by just from looking at it, we can state that x is going to be greater than y, because if x was less than y, then our solution to this equation would be negative, and it's positive, so x is greater than y, meaning that we can say that x is equal to y plus some number k. So now I can replace x with y plus k. So now I have 9 to the power of y plus k minus 9 to the power of y is equal to 648. Now if I have something in the form a to the power of m plus n, this is equal to a to the power of m times a to the power of n. So 9 to the power of y plus k, that's going to equal 9 to the power of y times 9 to the power of k. I have this minus 9 to the power of y is equal to 648. Now I'm going to factor out 9 to the power of y. So I get 9 to the power of y times 9 to the power of k minus 1 is equal to 648. Now 648, that's the same thing as 81 times 8. And if you notice here, 81, this is an odd number, and 8, this is an even number. So 9 to the power of k minus, 9 to the power of y, that's obviously going to be an odd number, right? So we can say that 9 to the power of y is equal to 81, and 9 to the power of k minus 1, that's going to be an even number, because 9 to the power of k is an odd number, and an odd number minus 1 is going to be an even number. So we can say that 9 to the power of k minus 1 is 8. So now this gives me two equations. 9 to the power of y equals 81. 9 to the power of k minus 1 equals 8. So for 9 to the power of y equals 81, y is simply 2. And for 9 to the power of k minus 1, I add 1 on both sides. So I get 9 to the power of k is equal to 9, meaning k is equal to 1. So now that we have the value of y and k, well, remember x is equal to y plus k, meaning x is equal to 2 plus 1. So x is equal to 3. So x is equal to 3, y is equal to 2, and k is equal to 1. Alright, so in this video, I'm going to be proving that 0 divided by 0 is equal to 2. So, for my proof, first start with 0 over 0. Now, this is the same thing as 1 minus 1, right? Because 0 is the same thing as 1 minus 1. So I have 1 minus 1 over 1 minus 1, which is 0 over 0. Now, this is the same thing as 10 minus 10 over 10 minus 10, right? Because 10 minus 10 is, again, 0. So I have 0 over 0 still. And this is the same thing as 100 minus 100 over 100 minus 100. Again, 100 minus 100 is 0, 100 minus 100 is 0, so it's 0 over 0 still. Now, 100 is the same thing as 10 squared. So 100 minus 100 over 100 minus 100, I'm going to write this as 10 squared minus 10 squared over, now over here for my bottom, I'm actually not going to write 10 squared minus 10 squared. Instead, I'm going to write 10 times 10 minus 10 times 10, which is, again, allowed. 10 times 10 is the same thing as 10 squared. I'm just not writing it as 10 squared. Now, if I have something in the form a squared minus b squared, this is equal to a plus b times a minus b. So in this case, I have 10 squared minus 10 squared, so that's going to equal 10 plus 10 times 10 minus 10. And from the bottom here, for my denominator, I'm going to factor out 10. So I get 10 times 10 minus 10. Now, I'm going to cancel these two out. So I have 10 plus 10 over 10, which is equal to 20 over 10, which is equal to 2. So I just proved that 0 over 0 is equal to 2. So obviously 0 over 0 is not equal to 2. And if you're wondering where the error is in this proof, it's in this step right here, when I canceled out the 10 minus 10 over 10 minus 10. 10 minus 10 is simply 0. So 0 divided by 0, remember, that's not equal to 1. 0 divided by 0, that's indeterminate. So I can't actually cancel these two out because that's simply implying that 0 divided by 0 is 1, which it's not. So this is wrong, and 0 divided by 0 is not 2.